We look up at the night sky, a vast expanse filled with countless stars and celestial wonders. It's a sight that has fascinated humanity for millennia, inspiring myths, legends, and scientific inquiry. Stars shine brightly, each one a distant sun, and planets move gracefully in their orbits. The universe feels alive, a dynamic and ever-changing tapestry of cosmic activity. But beyond the individual motions of stars and planets, we must ask ourselves, could the entire universe be spinning too? This question opens up a realm of possibilities that challenge our understanding of the cosmos. The idea of a spinning universe is strange and counterintuitive. It defies our everyday experiences and stretches the limits of our imagination. Yet, it's a concept that has intrigued scientists and philosophers alike. We usually think of things spinning in relation to something else. For example, a top spins on a table, a planet spins on its axis, and a galaxy rotates around its center. These motions are all relative to other objects. The Earth spins on its axis relative to the Sun, creating the cycle of day and night. This rotation is a fundamental aspect of our daily lives, influencing everything from the weather to the way we measure time. But what does it mean for the universe itself to spin? If the universe is spinning, it implies a rotation on a scale that is almost beyond human comprehension. It suggests a cosmic dance that encompasses everything we know. If the universe is spinning, it's spinning on a scale we can barely imagine. This rotation would be so vast that it would affect the motion of galaxies, the distribution of cosmic matter, and even the fabric of space-time itself. Imagine the universe as a giant ball, a cosmic sphere that contains everything within it. This ball is not static, it's in motion, with every star, galaxy, and particle moving in harmony. This ball has everything in it, stars, galaxies, even us. We are all part of this grand cosmic structure, interconnected and influenced by its motion. If it's spinning, everything inside is moving together. This collective motion could have profound implications for our understanding of the universe's origin, evolution, and ultimate fate. The idea that the universe might be spinning is a question that has puzzled scientists for a long time. It's a topic of ongoing research and debate, with new discoveries constantly reshaping our perspective. Let's explore what we know, and what we are still trying to discover. The journey to understand the universe's motion is a testament to human curiosity and our relentless pursuit of knowledge. To understand a spinning universe, we need to think about how things spin in space. The concept of rotation is fundamental in the cosmos, influencing everything from the smallest particles to the largest galaxies. When we look at objects in space, we often see them spinning, whether it's a planet, a star, or even entire galaxies. This spinning motion is not just a random occurrence. It follows specific physical laws that govern the universe. Think of a spinning top. This simple toy can help us understand complex cosmic phenomena. When you spin a top, it rotates around a central point, maintaining its balance and speed for a while before eventually slowing down. It has an axis, an imaginary line running through its center. This axis is crucial because it determines the top's stability and the path it follows as it spins. The same principle applies to celestial bodies. As the top spins, points farther from the axis move faster than points closer to it. This variation in speed is due to the distribution of mass and the forces acting on the top. In space, this concept is magnified on a much larger scale. This is true for planets, stars, and even galaxies. Each of these celestial bodies has its own axis of rotation, and the speed at which different parts move can tell us a lot about their structure and behavior. Now imagine this on a cosmic scale. The universe itself could be spinning, with galaxies and other cosmic structures rotating around a central axis. This idea opens up fascinating possibilities for understanding the dynamics of the cosmos. If the universe spins, galaxies farther from the axis of rotation would move faster than those closer to it. This differential rotation could create unique patterns and structures in the universe, influencing the formation and evolution of galaxies. This difference in speed is something we could potentially observe. By studying the motion of galaxies and other cosmic objects, astronomers can gather evidence to support or refute the idea of a spinning universe. It would be a sign that the universe is not static but dynamic, constantly in motion. This continuous movement shapes the cosmos, driving the processes that create stars, planets, and galaxies, and ultimately, the universe as we know it. Some scientists believe there are hints that the universe might be spinning. These hints come from observing the motion of galaxies. When astronomers look at distant galaxies, they've noticed something peculiar. The light from these galaxies is slightly twisted. This twisting is called polarization. While there could be other explanations, some scientists think this twisting might be a result of the universe's spin. Imagine the universe as a giant fabric. As the fabric spins, it twists the light traveling through it. This twisting could be the polarization we observe. Another potential clue about the universe's spin comes from the cosmic microwave background, or CMB. The CMB is faint radiation left over from the Big Bang. Think of it as the afterglow of the Big Bang. It's like a baby picture of the universe. Some scientists believe that if the universe is spinning, we should see a specific pattern in the CMB. This pattern would be like a swirl in the fabric of space-time. However, finding and interpreting this pattern is incredibly difficult. The CMB is very faint, and its signal can be easily contaminated by other sources. Section 5. The challenge of measurement. Proving that the universe spins is incredibly difficult. The concept itself is mind-boggling. Imagine trying to measure the rotation of something so vast, so incomprehensibly large, that it defies our everyday experiences. One of the biggest challenges is finding a fixed point of reference. In our daily lives, we can tell if something is spinning by comparing it to something stationary. But in space, nothing is truly stationary. To tell if something is spinning, you need to see it in relation to something else that isn't spinning. This is straightforward on Earth, but in the cosmos, it's a different story. But in the vastness of space, how do you find a fixed point? The universe is a dynamic, ever-changing place. Stars are born, live, and die. Galaxies collide and merge. Everything is in a state of flux. Everything we observe in the universe is in motion. From the smallest particles to the largest structures, motion is a fundamental characteristic of the cosmos. Galaxies move, stars move, and even entire clusters of galaxies move relative to each other. This constant motion makes it incredibly difficult to find a point of reference. Even our own planet is constantly moving. Earth rotates on its axis, orbits the sun, and the entire solar system moves through the Milky Way galaxy. This makes it incredibly challenging to isolate the potential spin of the universe itself. Scientists have to rely on indirect measurements and complex models to even begin to understand this phenomenon. It's like being on a carousel and trying to figure out if the entire Earth is rotating beneath you. The challenge is immense, but it's also what makes the study of the universe so fascinating. The quest to understand the cosmos pushes the boundaries of human knowledge and ingenuity. Section 6. Against the cosmic spin. Not all scientists believe the universe is spinning. There are strong arguments against it too. One argument comes from the principle of simplicity. In science, the simplest explanation is often the best. The idea of a spinning universe adds an extra layer of complexity to our understanding of the cosmos. Without definitive evidence, many scientists prefer to stick with the simpler explanation: the universe is not spinning. They argue that the observed twisting of light and patterns in the CMB could be caused by other phenomena, and we need more evidence to be sure. Section 7. The shape of the universe. The shape of the universe is also connected to the question of its spin. If the universe is spinning, it would likely have a slightly different shape than if it were not. A spinning universe might be slightly flattened, like a spinning ball of dough. A non-spinning universe would be more likely to be spherical. Scientists are still trying to determine the exact shape of the universe. They do this by studying the distribution of matter and energy in the universe. Understanding the shape of the universe could give us more clues about whether or not it's spinning. Section 8. Unraveling the enigma. The question of whether the universe spins is still a mystery. It's a question at the very edge of our scientific understanding. Answering this question requires sophisticated telescopes, complex mathematical models, and a lot of creative thinking. Scientists are developing new technologies and techniques to study the motion of galaxies in more detail and analyze the CMB with greater precision. Section 9. The quest continues. The search for an answer to the question of a spinning universe is a journey of discovery. Whether or not the universe spins, the pursuit of this knowledge expands our understanding of the cosmos. It forces us to confront fundamental questions about the nature of space, time, and the origins of the universe itself. The quest to understand the universe with all its mysteries is a testament to human curiosity and our drive to explore the unknown.